Hello everyone, I am Bhushan and I am going to present you today one of the highest trending topic in our industry, which is the data lake. Now lots of enterprises and startups are confused that what is this data lake, where to use this, how to use, when to use. There are so many queries going around, and believe me that there are lots of guys or lots of data architects who are giving their own definitions about data lake. Now let's start with the original definition, like from the creator, uh, from James Dixon. He is a CTO of Pentaho, and what he wrote that if you think of a data mart as a bottle, as a store of bottled water, which is cleansed, packaged, and structured for easy consumption, then the data lake is a large body in its natural state. What I mean is that the data is coming or the water is coming from various sources into my lake, and the end user will go over there. He can examine the water, he can take a deep dive, or he can take sample out of it. It's as simple as that. So in data lake is typically a data repository where from the data is coming from lots of sources and huge volume, whether it is a structured data, unstructured data, stream data, all kinds of data is coming over there. Now user will see that there are huge number of files, huge number of directories in typically a Hadoop system, or you can say a clustered system. And it's a kind of a processing, and data discovery is a kind of a iterative process. So you cannot like do normal EDW projects where you can do it one time. You keep on doing the discovery things in a data lake project. I'll take you that why we need data lake. Now you see that lots of enterprises are facing so many issues with their data actually. So I'll first give you that what kind of issues they are facing, and then I'll see that how the data lake will solve that problem. Enterprises data, you know that growing on twice, thrice, or almost 10 times in year-on-year basis. So they are facing a problem with a huge number of data and huge number of files coming over there. Also the complexity in their source data. Sometimes data is coming from the machine, from the source side, some from the social sites and all, and they are facing really problem to join or correlate that data. So that's a data complexity issue. Now suppose their data analyst wants to generate some analytics from a new data source. Now your architect has to analyze that data. He has to ingest that data, he has to write some ETL process, he has to do all the quality checks on top of it, he has to apply some security on top of it before giving it to end users. Now in this process, like your productivity will suffer, your agile development process will also suffer. Also like time to market will be slow in that case. Here like how the data lake will support you. So data lake will give you kind of a reliable and highly governed data which is readily available to the end users, so that they can collaborate very easily. You don't need to think whenever you required a new data set. Data set is easily available over there, so you can correlate very easily. It will improve your productivity. It will not suffer your agile development process. It will also like give you a fast time to market. Now I'll tell you that when to use data lake. Very interesting thing, like I'll give you a couple of scenarios over here. Let's say if you want to see a 360-degree view of a customer. Now you need a customer data, you need his demographic data, his location data, you might need the data getting from the third-party systems. So many places you are getting the data. Now you have to do the analysis on top of that data. Also, you need to reduce time and cost to analyze this data of a huge volume also. You need some like a rich data exploration things. You want to audit and tracking of your lineages, data lineage. Also you want to do the expanded discovery. For all these things you can use data lake. I'll give you a couple of examples how we use in our company. In the first place, we have used data lake for a company who are providing security solutions to enterprises and individuals. Now they are providing these solutions to so many users. There are millions of users, and they want to give their security updates and checks very fast to end users. So here the data is coming from large sources, data is coming in huge volumes, there are so many small files are coming, like millions of files are coming every day, and we have to analyze those files, keep on analyzing those files, so that before like something happen, we should predict that okay, this kind of a virus can attack. And for this system, like we have used data lake. And another industry, for in one of like a leading company in healthcare, what we are doing for them, we are getting the data from different sources. Like hospitals, we are getting data from hospitals in the EMR systems. We are getting data from the insurance companies. We are getting data from third-party systems. We need to ingest all the data at one place. Now the end users are very different actually. So there are data scientists who need the data into API format so that they can consume by their web services. There are third-party systems also which used by this analyst, so that they want data into particular format. So we have to like transform this data into particular format for those guys. So these are like a couple of scenarios. We are still doing like many more projects in our company for data lake, and this is like a couple of them. Now I'll give you kind of a logical view of data lake. Very simple. There are only 3 layers. In left hand side, you will see it's a data source layer. In your middle layer, you will see it's a processing and storage layer, and in the right hand side, you will see the visualization. Very simple thing. Don't need to think too many complex architecture over here. When you start with your data ingestion in the left hand side, as I explained, you can think about like data has to be ingested incrementally, batch mode, streaming. You can also take the data into bulk. Also, you can load your data lake from the EDW as well. You have to think about the storage format, what kind of format you use for the storage. You also think or prepare your strategies for partitioning and splitting of your data. In your processing and storage module, typically there are multiple modules over there. First one is security. Security is very important aspects as far as some of the industries are concerned, like healthcare and finance. Those industries have very strict compliance about their security. Security, when I mean security, is in 3 ways. First is when you are ingesting the data from your source to your data lake. Second is when the data will be resides in your data lake. At that time you also have to secure your data. Third place, the security when your data is coming out of your data lake and to be presented to the end users. At all 3 levels, you have to control your authentication, authorizations and permission levels. You can also control the kind of views, like suppose you want to give a particular source access to particular group, then you can control all those things in your security module. Second is my processing module. So processing module is typically ETL plus all sorts of processing what we used to do on our data in typical warehouse projects. It's like aggregation, joins, deduping, correlation, all those things what we are doing in the processing mode. We can also think about the data exception. If my data is not clean, I have to correct the data, I have to apply some error checks on top of that. Also I do some data masking so that data will be not available to some of those users if they are not authorized to see those things. And I can do the app specific business transformation as well. Third module in my processing layer is my governance and integration. So typically like data lineage tracking I used to do in this layer. I also like define a kind of a quality rules or quality engine for my system, which can be applied for all my data sources. Also I have to store metadata schema and relationship among those metadata components. Final layer is your visualization layer. So typically who is the users? Someone asked that who are the like internet users for this data lake. So there are many users like data scientists, your data statistician, your developers, your business users, CXOs. Surprisingly, even IT and admin guys are using this data lake for their auditing and archiving purpose. So what they are doing typically, they need to explore the data, they want to visualize this data, they want to like discover or correlate various different data sources. They can create or they can use a kind of a query languages which to directly query your HDFS or your file systems. They can also like get this data from their web services in the form of REST APIs so that they can apply the rules over there. Now I'll give you like what is a typical flow in your data lake. So how the data is typically flow from one place to another place, and what are like typically checkpoints over there. So first one is like your ingestion. You have to ingest the data in the incremental, batch format, stream format, whatever you need actually. So what all formats are supported should be supported in your data lake. Second is, once you get the data, you have to mask your data, you have to secure your data from anomalies. Security is very, very important. So data security is, you cannot like go away with. Fourth point, once you like get the data, now it's a processing part. So you need to process that data, you need to refine that data, you need to curate that data. So the data will be in a proper format. If your quality of your data is not good, end users will not able to consume that, or they will not consume it for their analytics purpose. So quality, you have to maintain the quality of your data as well. If you process, once you process those things, you can move some of your data to your EDW, so that the traditional reporting tools or analytical tools can use as it is what they used earlier. Once the data is available in your EDW, also like you can use pass it to your data visualization tools for exploration and analytics purpose. They can also directly query your data using the web services, so that we can subscribe those users with the help of REST APIs, or also we can enable them so that they can get the data, they can export, or they can import the data from your data lake. So these are typically like workflow for that. Now I'll give you that what kind of tools available at each level. There are lots of tools available in your big data and this ecosystem. So don't worry about like thinking about like so many tools. Just choose a proper tool which is enabled or which is required for your project. There are lots of tools available in the market. And in data ingestion side, if you see, there are Scoop, there are Kafka, then traditional tools like Talent, Informatica, those are also available. In analytics, like you have Spark, you have like Big SQL, Presto, Hive, such kind of tool. Real-time processes, you have Spark, Storm, Kafka again over there. Storage side, very important, that people always think that data lake is always about HDFS and Hadoop system. It's not like that. You can use storage like NFS, you can also storage like S3. It's very important. You can use any kind of storage for your data lake. It's not restricted only for your Hadoop system. For visualization layer, again lots of good enterprises or good companies who are providing you good analytical tools, like Tableau is one of them who is leading in industry. There's a ClickView is there, MicroStrategy is there, SAP is there. Also like Share Insight from Persistent is one of the tools which we can use. Hive SQL is another tool from where you can query your database or directly the file systems. I'll give you something about best practices when you design your data lake. There are lots of best practices over here, and it's this data lake as a concept is growing. You'll see more and more best practices in coming days, but these best practices as far as like our experience is concerned in this industry or in the data lake projects. First, I'll give you that always think about or focus about the architecture of services and API. What I mean by that is data lake is always driven by what is available rather than what is required. What I mean by that is that when the data is, you always think about how to source the data from different data sources. You never think about that when I use this, how I use this. So structure and the schema will be defined later on. First, you always think about ingestion, the data ingestion part. You have to create lots and lots of components, and which will be correlated through the help of service APIs. Now, as I know that you will create lots and lots of components or small components over there, so that data discovery and ingestion, your storage and administration, your quality and transformations, and visualization and interaction, these 4 layers has to be managed and developed independently. Believe me, these layers has to be managed independently. Second part in your design consideration, that you have to support for your native data types and specific industry. What I mean by that, that you know that in data lake you are using too many sources, disjoint sources, some is your structured, somewhere it is unstructured. Always think about that these all sources should talk with each other in their native data types. Otherwise, what happened that this different your sources will work as a silos, and you will not able to like correlate them. You will not able to use the like facilities provided by data lake. Also, whenever you define or design any data lake your program or project, think about the industry for which you are developing this data lake, because audit norms, security norms, compliance of different industries are very different. So whenever you design your data lake for a specific industry, always think about those security norms, always think about those compliance which are used in those industry. Another design consideration is think about the data servicing and governance. Very important that how fast I can able to ingest the data from a new data source. I can able to enable, or I can enable my data lake so that it will very fast ingest any data source very rapidly, which is very essential when I think about time to market. Another thing is that data profiling, policies, lineages and security must be enforced, because security has to be enforced in your data lake. Other important aspects of this platform are data monitoring, data tagging, parsing, correlation. These are also very important, and you have to think separately about these modules. Another design consideration is search over data lake. Whenever you create a data lake, always think that it has to be used by your end users. So end users, you have to give them the capabilities so that they can search very easily. If they are not able to search on your data lake very easily, they will not use that thing. So you have to enable the end users so they can very easily correlate, or first they identify what sources I need. They can able to like unify those sources. They can able to correlate those sources from their own. So you give them end users the ability so that they can do their queries on this data lake very easily. And final point is your metadata management cannot be an afterthought. What I mean by that, you always do the metadata management in your entire life cycle of your data lake projects. You keep on discovering your data sources, how the data is coming, how my metadata has to be like moved, has to be improved, because some of the data sources will be removed, some of the data sources will be changed. So keep on doing the metadata management on top of it, or like on the regular basis. You can automate this process also. So all the like 4 steps like extraction, analyze, correlation and tracking has to be automated. There are a couple of tools available like HCatalog, Waterline, Loom, and Ativio. Like so many tools are available for your metadata management. You can choose any tool based on the requirement. Final takeaway from this session, yes, very important. First is to know your source. Definition given by one of the scientists is data lake is data first, schema later. What I mean by that is that always think about I need the data from various sources to be ingested in my data source. I always think about the schema or usage of this data later on. Always keep on discovering for the new sources. You never sit idle, okay, if I ingest a couple of sources and that's it, my data lake. It's not like that. You have to keep on discovering new data sources. So many new data sources will come and required for your analytics. So study them well. Whenever you get any data source, you should study them really well. You should understand their characters. You should understand their ingredients. You should understand that how they will correlate with each other. You have to like study a lot about any new and existing data sources. Improved analytics. Once you know that what kind of a sources you are getting, then you can do metadata management on top of that, and then you see that how like fast and improved analytics is there actually. So if your data is correlatable, you can able to correlate one source with another source. You can join couple of sources, disjoin sources, then and then you will able to do the fast analytics, also the improved analytics. Fourth one is measure and monitor. Keep on measuring your systems. Your measurement should not be based on your consumption of your data. It is always based on what is consumed like. So how much user is consuming, not like volume what you are sourced as of now. So consumption is very important over there. Your new data sources will keep on adding. You might need to remove some of your data sources. You might need to edit some of sources, because source definition will keep on changing, structure definition will keep on changing, and you have to keep on monitoring and keep on changing your process or metadata time by time. Final thoughts are, do not overbuild. What that means is, it's a kind of iterative process. Big data is also evolving over time. So don't think about ingestion of all the data sources at one point of time and just get finished. You keep adding couple of sources and keep on adding on top of that. Let your data lake build time to time, and add one source at a time on top of it, so that it will gradually increase as far as the structure and storage is concerned. Final point for this is, focus more on analytics and insight, and don't think about the quantum of data you are having over there. So always think about the improved analytics. And from that points, I'll end my session. Thank you so much.